We go on with how to set selling price. Okay. Now there are many pricing strategies out there. Okay, many ways of how you can set selling price. So the first one that we're going to discuss a bit more with some numbers to calculate is what we call demand-based pricing. And what is this demand-based pricing? See, it's actually a way of how we set selling price that we base on the demand. Okay, so we want to set a selling price according to the demand that we want to stimulate. So if you want to sell 5,000 units, then what price do you set so that you can set 5,000 units? You can sell 5. That's why it's demand-based pricing. Now, the purpose of why we use demand-based pricing is because we want to go for an optimum price. Okay, we want to achieve this thing called optimum price. And what is optimum price? That we believe theoretically, optimum price is the selling price that maximizes return. That this is the price you set, it will give you certain demand, and selling at that level, it will give you the most return. Okay. Now, but to understand the idea of how to maximize return, before we talk about pricing, we discuss about this concept. Okay. So let's look at a concept called marginal revenue, marginal cost. Okay, we look at a concept called marginal revenue, marginal cost. Now, marginal means incremental. This marginal means incremental. So if I tell you like 1 unit, okay, I don't use selling price, I say sales. Okay. Now 1 unit, my sales is $50. 2 unit, my sales will be. Now, of course, if you are assuming that everything is constant, that means the price is not changing and the cost is not changing, then of course you say 2 units is 100 lor, 3 units is 150 lor, 4 units is 200 lor, 10 units is 500 lor. You will say like that, okay? Now, but we are trying to be more realistic, that we look into an actual environment. We understand that when you sell more, right, customer will ask for discount. They will not say 2 for 100, 3 for 150. Right? No? You go Chichonkai buy things also, you buy 3, you bargain. Okay. So when you start bargain, maybe the guy will say, okay, 2 I sell you 85. Now when 2 sell 85, effectively you can see by selling 1 additional unit, your marginal revenue is 35. Okay, and this marginal revenue may not be the same in the sense that you can keep reducing the price, so the marginal revenue might fluctuate. Understand? Okay, now example, maybe when I sell you 3 units, right? Now I say I give you cheaper. Okay, so what I'll do is I charge you 110 only. So this shows that again, from 2 unit to 3 unit, your marginal revenue become 25. See that? Okay. Now, so this is the meaning of marginal revenue. What about marginal cost? Same concept. It's the incremental cost of. Now, to be more so-called accurate, when you say marginal cost, the cost should be based on when you sell the product. But there are people that they don't talk about selling, they can talk about production. That when I produce, there's already a cost. And when you produce, then the incremental cost is the production cost. But if you are talking about when you sell, right, then it's the incremental cost of production and sale. So it's the incremental cost of production and sale. Now why I must put it like that? Because you know we have production costs and we have non-production costs. So if you're talking about selling, right, you should take a production and sale. So if I tell you the first unit, assuming the first unit, my cost is 20. Now second unit, if my cost is constant, it won't change. It's 20. That means my marginal cost is 20. Now imagine if my third unit, my cost is 60, then my marginal cost is still 20 also, right? Now if I tell you 4 unit, my cost is 80, then my marginal cost is also 20. Right? Now that's why you see, when your cost is constant, they don't change, there's no discount. Marginal cost is variable cost. That's why when you learn marginal costing, we tell you marginal cost is variable cost. Now that's because we are assuming that they are not changing. That's why you see the cost is all the same. Because you know, they are just the variable cost. Okay. So now you understand what's called marginal cost and what's called marginal revenue. Huh? Okay. Now if you understand this, we do an experiment. You become a hawker down there in Petaling Street. Okay. So you sell, what do you want to sell? Mango, bag, t-shirt. Never mind. Let's say you sell t-shirt. Okay. So when you sell your product, now your cost per unit is $10. Okay, your cost per unit is $10. So let's say there's a customer come and say, I want to buy 1 t-shirt. Okay, I'll buy 1 t-shirt. Now the t-shirt price, let's say, is 25. So your cost is 10. Correct or not? So you sell or not? Of course you sell lah. Okay. Now he offer that he buy 2, but must give discount. So he say, I buy 2 t-shirt from you, instead of $50, you charge me 45. Okay, your cost now become 20 lah. You sell or not? Of course you sell, right? Okay, you still make profit. So now this guy say, hey, buy more, cheaper. So he start to ask, I want to buy 3 t-shirt. Okay, you give me even more discount. So the guy start to offer that for this 3 t-shirt, you sell me, let's say for example, $60. Okay, the cost is, one cost is 60. 30. You sell or not? Sell. So now he come to last price. I say, okay, I don't bargain already. This is last. 4 t-shirt, 69. Okay, because you buy more, you give me more discount. The last price is 69. What's the cost? 40. My question, sell or not? Sell. Betul ah? Tak menyesal. No regret.买more ah? Hả? Mày á? Tím cái? Tím cái? Because you got profit, that's why you sell. Now, see, the idea now is to explain to you the concept of marginal revenue and marginal cost. Okay, let us calculate the net profit first. 25 minus 10 is 15. 45 minus 20, 25. 60 minus 30, 30, right? 69 minus 40, 29. See, for the one who say you want to sell, you think back and see. When he offer you 60 for 3, he agreed to buy. He bargained against 69 for 4. If you also want to sell, you make less for. You might as well don't sell. You say no. Last price, 3 for 60, no more. You buy lah. You don't buy then never mind. Now why? Because at this level, your profit has reached maximum already. You cannot go up already. Okay. So if you want to bargain some more, now it will reverse back. Okay, your profit will start to drop back because it's too cheap already. Now, so this illustrates the concept of marginal revenue and marginal cost for us. And I'm using a situation that the marginal cost is the same. Now, my marginal revenue is 25, my marginal cost is 10. From no unit to first unit, 25 and 10. So, incremental revenue and incremental cost, the difference is my profit. Now, then when I sell the second unit, I make 20 increase in revenue, right? 25 to 45 is 20. Right? Now then my cost increased by 10, right? Now? As long as the marginal revenue is still above the marginal cost, your profit is still going up. That's why now you see 20 over 10, you earn extra $10 already. Compare with just now 15 plus 10, that's why it's 25. Now when you offer me to buy the third t-shirt at 60, you offer me $15 marginal revenue. And my marginal cost is still 10. That's why you make me extra $5 of profit. That's why from 25 now become 30. Now, but when you offer the fourth t-shirt at 69, the marginal revenue is only $9. Marginal cost is still 10. So now when the increase in revenue is less than the increase in cost, the effect is profit start to decline. And of course now the decrease is $1. The $1 will cause the profit to reduce by $1. Now that means initially you will see that your total profit it was increasing, okay? It was increasing with the number of units you sell more and more. That's because marginal revenue is still bigger than marginal cost. That's why the profit is still go up. But then, the theory of marginal revenue is, as you sell more and more, marginal revenue tend to get smaller and smaller. Because all customer behavior is, when they buy more, they want discount. That's why they will not stick on to you and say that, one unit is 10. I buy 10 unit, give me 100. No customer like that one, ma. Can you say not? I buy 10, give me 100. They don't buy 10, you buy 5, buy 4. So say, once you say, I offer buy 10, give me 90. You want cheap. Now I buy 20, give me 150. You will make it cheaper. So that's why the logic is marginal revenue will decline. You see that? 25, 20, 15, 9. You're going to become like that. So as your marginal revenue decline, it will come to a point that the marginal revenue become less than marginal cost. And it will even be crossover. That is like this. So once they cross over, then your total profit will start to go down. Now that is because marginal revenue is now less than marginal cost. That your profit start to drop. So based on this theory, we are saying that at this point where you get maximum profit is a point when marginal revenue will equal to marginal cost. Because that is the changing point. That initially marginal revenue is still higher, but because marginal revenue will keep reducing, it will reduce and reduce until a point, theoretically, that marginal revenue becomes equal. Now that's where your profit is the highest. Because after that, the marginal revenue will start to drop. And when they drop further, marginal revenue becomes less than marginal. Now in that case, your profit will start to decline. Now that is the relationship that we see. MC equals to MR will give you maximum profit. Okay, now MR equals to 0 is another relationship. MC equals to MR is relationship that give you maximum profit. If MR equals to 0 is a relationship that will give you maximum revenue. Now I just want to tell you what is MR equal to 0. I tell you this first, okay? Now why we say this is maximum revenue? Now, you see an example. 1 unit, let's say you sell at 8 lah. So your sales is 8, marginal revenue is 8 lah. Now the guy offer, I want to buy 2. Okay, you discount $1 for me. 14, right? So MR is 6. Now the guy say I want to buy 3. I want discount $1 more. So 3 times 6 is 18, no? It become 4. Now you realize or not, every time when customer demand for a discount, you will see your sales is still going up, because originally is $8, then it's 14, then it's 18. See, your sales is going up. But as your sales go up, you notice marginal revenue is getting lesser, because you get lesser now, because it's selling cheaper. So now this guy say he wants to buy 4 units at $5. How much you get? 20, no? And your marginal revenue is 2. And what do you imagine next? He say, I want to buy 5 units, but you give me $1 more discount, which of course you say 气心. Buy 4 units at $5 is 20. Then the fellow say, I want to buy 5 units at $4, also 20. I mean, like that also you sell, you must be crazy. Can you know? Now, imagine the guy say, I want to buy 5 units, but you give me discount some more $4. The price is still 20, right? So now what do you see in the marginal revenue? 0 already, cannot increase already. That's why theoretically we are saying, you increase until the marginal revenue cannot increase. The MR becomes 0 already, is where your sales has reached the max. cannot go up already. In fact, if you go on some more, let's say the guy keep asking for this guy, I buy 6 units, you sell me $3. Well, that's even worse. You get 18. Your marginal revenue not only is stopped, it start to drop. Your total sales is even lesser than before. So that's why from here we say, as MR is declining, when MR decline until cannot decline, 0, your sales will reach maximum. That should be the highest sales again. Now, so this is a simple example to show and explain to you why we say MR equals MC, profit is highest. MR equals 0, revenue is highest. Now, revenue highest doesn't mean profit is highest, okay? Okay, so you understand this concept already? Now, I'm going to use a simple diagram and illustrate for you. Okay, now this is the value you get, that's the quantity you have. Now, assuming if I say that marginal cost is at a constant variable cost per unit, no discount, okay, 1 unit 20, 2 unit 40, 3 unit 60, 5 units 100. So the marginal cost is just 20. If your marginal cost is just 20, no discount, no adjustment, then logically, let's say the line is a flat, straight line. Marginal cost is straight. Okay? Now, as what we discussed just now, marginal revenue reduces the more you sell, correct? That's why your marginal revenue, let's say at 25, it becomes 20, 18, 16, 8, 5, 4, 0. It will just keep on going down because customer asks discount. So this is my marginal revenue. And theoretically, when your marginal cost and marginal revenue equal, this point, that should be the point where profit is maximum. Okay? Now, so I use number to see you the logic. So first I know marginal cost, then I know marginal revenue, then I can find the point that cost and revenue equal. Okay? Okay, so if you have found this point, then what you're going to do with it? Now, what you're going to do is you will ask yourself, at this point, what is the quantity that you need? So you go down and ask yourself, what is the quantity? So say that quantity is 5,000. Now I simply say, I just simply put a figure. Let's say based on the graph, I can read in the graph that when these two lines equal, if you go down, you can see the quantity is 5,000. And what does the 5,000 tells you? The 5,000 tells you that selling at 5,000 unit, you get maximum profit. Because at 5,000, your MC, MR equal, and when they equal, profit is maximum. That's why this is what 5,000 meant to you, that at 5,000, you get maximum profit. So now my next question is, if you want to sell 5,000, what price must you set? So that was the question. Okay, so if you know this, then the next question, so to sell 5,000 units, what price must you set? Now you need the price demand function. P equals A minus BQ. And class, by having P equals to A minus BQ, you're going to draw a straight line which will show at what price, what quantity you sell. So imagine now by having that P equals to A minus BQ, you've got number 6. You've got that line already. Okay, and you know when you come to this line, you now got your answer. How do you get your answer? Now the answer is very simple. If you know this is the same quantity that we want, okay, this is the quantity we want, and you ask to sell this quantity, what price do I set? So I will have this line called P equals to A minus BQ. This line will tell me if you sell at certain amount, what is the quantity? Or if you want certain quantity, what should the amount be? So that's why if I go back using the same line, I notice that this line come here will show me the amount. Now that is optimum selling price. Okay, that is optimum selling price. So again class, which means if you sell at this price, you will sell at this quantity, and this quantity is the quantity that MC equals to MR, and that is the quantity that will give you maximum profit. So this price gives you maximum profit. Now that's the theory. Okay, so now if you want to do this technique, you want to use this technique, then what is important? Important is you must know how to find what is the Q. You don't know how to find Q, you can't use this technique, right? Correct. That's why if you want to use this technique, it's very important for you to determine what is the quantity. Then number 2, you also must know how to find this. Where you don't know how to find this, then how do you use the quantity and replace back here to find the price? So it's mathematics only, that you must know how to find this and how to find this. Now, which is what I'm going to discuss now with you. Okay, so I will first show you how do you get this. Okay. How do you get P equals to A minus BQ? Now, if you are talking about cost, let's say I draw you a line. You tell me this line is what cost? Variable, fixed, or mixed? Mixed. You tell me what is this? Fixed cost. So if I say this amount is 15,000, then it will be Y equals to 15,000. Then plus BX, right? And B is what? variable cost per unit. X is what? Quantity. So X is the quantity, Y is the cost, V is the variable cost per unit. How do you find V? How do you find variable cost per unit? You take high-low method lah, don't know meh? Huh? You find V by taking the change in cost divided by, yes. You know this. If you know this, you don't know this, something is wrong because it's the same thing. We call it P simply because we want to coincide with price. That's all. You don't like P, change back to Y. You don't like Q, change back to X. It doesn't matter. Okay? A plus or minus? Y minus? Because the shape you see, right? Plus go up one, minus will go down one. So that's why it's minus. This is plus. Okay? Now you minus because we know when the price is high, people don't buy. When the price is low, people buy more. It's terbalik. That's why it's minus. Correlated in a negative way. Okay? Okay, so what is A then? A is what? Fixed cost. So what is A? Here. Now this is A. But A is not fixed cost now, because this is not cost. This is the relationship between price and demand. Tell me, if your price is A, right, how many units can you sell? 0, exactly. You take so long. You all see, that's why you all eat lunch, okay? Now, A is price when demand is new. Do you know how to find A? Got learned before, not? Got or not? Don't have? Huh? Got? Got. When? Huh? Linear programming. Wow, very far away. Okay. When did we learn price when demand is new? It was just before lunch. Sega? That's why I say lunch is very bad one. Now you don't believe, I show you. This page is what we discussed, right? Now, well, just one page only. Well, the one page like 10 years back, you know. Selling price where demand is new. I just taught you just now how to find that amount. Now, and the reason why I taught you is because I say I need this thing here. Because when you look at P equals to A minus BQ, A is price when demand is 0. And what is B? Change in not cost lah. Now it's not cost. Now it's change in price divided by change in quantity. That's it. Simple. Huh? Now this is how you get P equals to A minus BQ. A is the price when demand is croissant. B is change in price divided by change in quantity. That's all of it. Okay? Now how do you find A? Now one way to find A is you use this formula. Current price plus current quantity divided by change in quantity multiplied by change in the price. That's how you do it. Okay, we try a few examples here. See class, it says that product V has a sales demand of 150 units at the price of $10. If the selling price is changed to 11, the demand fall by 18 units. Okay, what's the price demand equation? Now, I want P equals A minus BQ. We only need to find A and B only. Okay, because P and Q is just a variable. Okay, so what is A, class? Okay, price when there is no demand. How do you find? What's the current price? 10, 10. And at $10, you can sell how many units? 150. So when will the price have no demand? When your price increase. And increase by how much? Now, demand drop by 18 every time when they change by $1. That means I can divide by 18 multiplied by $1. So you realize that at the price of 18.33, you have no demand. Now this is A. So you have one figure. Okay, minus B plus, how do you get B? B is change in price divided by change in demand. Okay. Now, this is easy, senang. What you do, right? Take this and take this. Tarik keluar. Now, this is the change in the price. This is the change in the demand. So B is 1 out of 18. You want to convert it to decimal point also can. But if you convert to decimal point, you get a number like that, 0.0555. Then some student will round. If you round, you say what, 0.056. Then later your calculation will not be so accurate because you are rounding the figure. So if you don't want to have this problem, then you maintain as a fraction. That means you just put in the answer 1 out of 18 cube. Also can. Okay? Follow? Now, that's how you come up with equation. Okay. Last two. The product B has a sales demand of 2,000 units when the selling price is $3. However, when the price reduced to $2, the sales demand will increase to 2,008. Now, assuming the demand is linear, what's the price demand function? Now, you're going to do the same thing for me. Help me to determine what is P equals to A minus BQ. 1 minute. Okay. So we start with A, right? A must be current price, $3. And current demand is 2,000. If you say 2,000 increase to 2008, it's the same. Change is 800. And the change is based on 3 drop to 2. That means the change is $1 as well. So 2,000 divided by 800. A is 5.5. What is B then? Now, you take this and this, you pull up. So it's 1 out of 800. Now, if 1 out of 800, you're going to get something like this. 1 out of 800. (1.25) power of negative 0.3. So how do you solve this? Now, the negative 0.3 is the position of your decimal point. So when it's negative, you want to convert it to full value, you push it to the front. So negative 0.3 means you must push 3 times. That's what we learn in maths. So 1, 2, 3. That means it's 0.00125. Okay? Now, so it's 0.00125. Now, if you're not sure in the exam, right, what you do, you type one more time, 0.00125. Okay? And then you press equal. You get the same figure. Then you check again. Then correct, because the figure is the same. You just type once more, then you will see. If in case you don't know how to read the value. Now, or you don't want this decimal, then put 1 out of 800. The answer is the same. Okay? Now, this is ELAS 2. Okay. There is a tendency that students will mix up B with PED because they sound quite similar. Price elasticity of demand is measured by taking what? Change in demand divided by change in price. Wrong. Wrong. It's not change in demand divided by change in price. Percentage. It's percentage change in demand divided by percentage change in price. That's PED. B is just change in price divided by change in demand. Now, so it's not the same thing. So I just give this example to make sure that you see them clearly. Okay? Product A has a sales demand of 5 million units when the price is at $5. And when price reduces to 4.5, demand rises by 400,000. Calculate for me what is the PED. And now also determine for me what's the price demand function. You do this one. I want 2 things now. The PED and the price demand function. So the formula for PD is percentage change in demand divided by percentage change in the price. So the example said that if you change price from 5 to 4.5, demand rise by 400. So if I take 400 out of 5 million times 100, so the change in demand is 8%. And the change in price is 0.5 from $5. 5 to 4.5, so the change is 0.5, and the change is from 5, so the change is 10%. So the PED is negative 8 divide 10, so it's 0.8. So in terms of calculating PED, that's what you do. Okay. Now in terms of calculating P equals to A minus BQ, then we do different thing again. Now first I need to find what is A. Okay, price when there's no demand. Class, what's the current price? $5. And the price increased by 5 million out of. Now you can change by 0.5, and then demand will change by 400. So 5 million divided by 400 times 0.5 plus 5, you're going to get A as 11.25. And what is your B then? So your B will be these two figures pull out, 0.5 divided by 400,000. Okay. Now if you take 0.5 divided by 400,000, you're going to get an extremely small figure, because it's power of negative 0.6. You have pushed the decimal point by 6 times. So I think I don't want to have that figure. I just use a fraction. Now, and I don't think I want to use 0.5 because funny lah. So I just make it 1. So times 2, that means 1 out of 800,000 cubed. Or if you just maintain 0.5 out of 400 also, it doesn't matter, it's the same. Okay. Now this is your price demand function. This is PED. It's different thing. Okay. Okay. So how to get P equals to A minus BQ, you know already. So now I will discuss with you the next thing. Okay, done. Now, how to set optimum price? Okay, class, you see, we look at the logic so that you know why we do it in that way. Okay, now P equals to A minus BQ. Correct? What is this? Price. This formula represent price. Represent price. Now, tell me what will happen if I take price and Q multiply. What do you get? If you got price and then I multiplied it with the Q, you get what? Sales. Yes. So we call this as total revenue. I don't call sales, I call it as total revenue. Total revenue is AQ minus BQ squared. Okay, total revenue is AQ minus BQ squared. Logic, we're just using mathematical equation, alright? So P times Q is total revenue. Now, but we don't want total revenue because what we need just now is marginal revenue. That's what we say, what? MR equals to MC. So what we want is MR. It's not the total revenue that we want. So we want to take total revenue, convert it to marginal revenue. And how do you take total revenue and convert it to marginal revenue? Now, statistically, we do differentiation, which I will just show you the technique what we do. So we take AQ, Q is power of 1. So you must take the power, throw to the front. So it's 1 times A. Q power of 1, when you throw 1 to the front, it will loses 1 of the power. So it becomes 1 minus 1. So it becomes Q power of 0. Q power of 0 equals to 1. Anything power of 0 is 1, okay? And BQ power of 2, you must throw the 2 to the front and then minus 1 because it lost 1 of the power, okay? Now, so effectively, I'm not interested with the power thing, don't worry, okay? I'm just telling you that why it's like that. So effectively, MR equals to 8. It goes back to 8 because 1 times A times 1 is A. It goes back to 8. 2BQ because 2 minus 1 is power of 1. Power of 1 equals to Q. So MR is 2BQ. So class, from here I have just shown to you how you get MR. So always remember, let's say if I tell you P equals to, let's say, 500 minus 3Q, okay? Let's say it's like that. Now then MR will always be 500 minus 6Q. It's always like that because you just have to take B times 2. That's all. So I don't need you to remember all this, but I'm just telling you why we do it in that way. Why the MR is always 2 times the B is because of this relationship, okay? Now, so MR is always A equals to 2BQ, okay? Now, if you know what is MR, then you have to put MC equals to MR, insert them inside the equation, and find Q. Now, this become quantities that maximize the profit. Okay? Okay. What you do, P equals A minus BQ. You know what is A, you know what is B, right? Because A and B is always a value. Is it 500 minus 3Q? So if you know what is A, what is B, now you've got what is Q also, because you know what is Q already. You just have to throw the Q inside, then you solve the whole equation. That's why you use back P equals to A minus BQ. Take this Q, dump it in, then you've got P. So that is how we set the selling price. Okay? Now, so it's just a little bit technical, alright? Now, but this sort of thing, if examiner asks, is bonus. Very simple question, can be 10 marks. Just find what is the equation, then find what is MCMR, then calculate what price that will give you maximum profit. Like that, only a few steps, only 10 marks. So if examiner asks, it's a bonus. Okay, turn to page 102. Okay, let's look at illustration 1. Now, I'll show you the steps of what we say just now. RJD makes and sell a single product, Z, and that the selling price equation is given. Now, they're given you the selling price equals to 50 minus 0.001x. Now, what is this? This is P equals to A minus BQ. You read, you should know, right? Okay. Okay, then in the example, they say variable cost will be 20 per unit. Now, variable cost is marginal cost. Because if your variable cost is fixed, it must be the marginal cost. Okay. Okay, then the fixed cost is 100,000. Now, the question asks, calculate for me what price that will maximize profit. And then the question asks again, calculate for me what price that will maximize revenue. So what's the difference? Plus, to maximize profit, MC equals to MR, or MR equals to MC. But to maximize revenue, MR equals to 0. Always remember that, okay? That's how you maximize profit, maximize revenue. Okay, I'll show you the answer. Okay, first step, you must find Q. To find Q, you must know what is MR. MR is 50 minus 002Q. You straight away know the answer, correct? Okay. Why? Because take P equals to A minus BQ and convert it to 2BQ. That's it only. That's why I just straight away take this, change to 0.02. Now, if MC equals to MR, where MC is 20, that means 20 equals to 50 minus 0.002Q. Right? So this is MC. This is MR. So MC equals MR. This is the relationship that profit is maximum. Okay, if this relationship is profit equals to maximum, then you tell me, based on this, right? Q is what? You work backwards up, okay? So 20 minus 50 is 30 divided by 0.002. Q is 15,000. So class, if you sell 15,000 unit, right, this is the quantity you sell, profit is the highest. But now the question is, how much you need to sell so that the demand is 50? So now we go back to this formula. Because this is the formula that gives you the price. So 50 minus 0.001, now the Q is 15,000. So 35. So theoretically, if people ask you, okay, tell me what price you sell, you get most profit, $35. Okay, sell 35, you get the most profit. Okay, Not all, there's not all. Question got two parts. Tell me how much you need to sell so that the revenue is highest. Okay. I write the title first. This is profit maximization. Okay? Okay, I do at the side lah, easier to see. Now, revenue maximization. MR equals to 50 minus 0.002Q. Revenue is maximized if MR is 0. In that case, 0 equals to 50 minus 0.002Q. See, now I'm just changing this to 0 here. Now class, this is what we have. Then what should Q be? You get Q as 25. And if you get Q as 25, right, you put back this into the equation. 50 minus 0.001Q. 50 minus 0.001 times 25. Then you get 25. So class, $35 is the price you sell. Give you maximum profit. $25 is the price you sell. Give you maximum sales. Why don't we just prove it and see? Okay, why don't we just prove it? Okay. So let's say I work it down here lah. Now, if you sell at 35 and you sell at 25, okay, you sell at 35 and you sell at 25. Okay, what's my demand? $35 got how many units? If I sell $35, how many units do I sell? 15, no? That's what you see right now. Sell 35, the quantity is 15. So 15. If you sell 25, 25,000 units. Now, you see, $35 times 15 is 525. So class, mana lebih tinggi? 625 is higher, right? So am I right that if you sell at $25, your revenue is more? Alright? In fact, this is the highest. Your revenue is highest. You don't believe, you go and adjust the price. You use back the PD. You see, if I take 25, I reduce it to 20. 25, I increase it to 30. You calculate. This 625 is the highest. Nothing can be higher than that. Okay? Now, so the sales is highest at $25. But now you put in the variable cost. Now variable cost is 20. So 300,000, 500,000. $225. So I hope you see from the results that we've calculated, this 35 maximize the profit, but 25 maximize the revenue. See the difference? Okay. Okay. Now you try for me illustration number 2. Calculate for me in illustration 2 what is the price that maximizes profit. Where it says that D produces product G, G is estimated to have a demand of 20,000 units if it's based on the selling price of $19. If price increased by 1, demand will fall by 500 units. The variable cost is 6. Now, the first step you must do is you need to find P equals to A minus BQ. You don't have that, you cannot find MR. So you must find P equals to A minus BQ. So what is P equals to A minus BQ? Now, A is the price when there's no demand. Now they say now that your price is 19. So the price when there's no demand is 20,000 is the current demand. Demand will change by 500 whenever it changes by $1. So the price with no demand will be 59. And what is the B? B is 1 out of 500, which is 0.002 Q. Now you have got one step done already. See class, once you've got this done, right, second step, MR. MR is B times 2. That's all I need. That's the second step. Take this times 2. And class, once you got MR, right, we have to maximize profit if MC equals to MR, where MC is how much? 6. So 6 is 59 minus 0.004 Q. In that case, Q is what? 13,250. And if you know Q is 13,250, now you will take this and put it back into the price function. So if P is 59 minus 002Q, it will be 59 you should get it as 32.5. okay? So I hope you have no problem with this. Alright, now we do one last one. Okay, now I'll give you a short break. Okay? Now they say Johnson has recently produced a material called Nero. And they've given you the cost of Nero. Material cost is 5. Labor cost is 3. Overhead variable is 3. Fixed overhead is 4. Variable selling is 1. The total fixed production overhead is 400,000 a period. Now the management has established that a linear relationship between the price and demand, that if based on the price of 50% total cost plus, it will have a demand of 300,000. And if the price reduced by 10%, the demand increased by 45. So based on this story, now work out for me what price optimizes the profit. Okay, what's the optimum price? What price will give you maximum profit? Follow the same step. Start with P equals to A minus BQ, and then do MR, find Q, replace back, get the answer. Right, so the issue we have here is they never give you the price exactly, okay? So they only tell you a hint that the price is 50% total cost. Now, that means at 50% plus total cost. Oh, sorry. Okay. Total cost is how much? 16. So that means if at 50% plus 16, so it's 24. So at 24, demand is 300,000. And if your price cut by 2.4, demand increased by 45. So the first info you must have is you must have sorted out this figure, okay? Okay, so now we know P equals to A minus BQ. A is current price plus current demand divided by change in demand times change in price. So the 300,000 divided by 45, you get it as 16. So A is 40. What is B then? B is 2.4 divided by 45. Okay, 2.4 divided by 45. Now this is your P. Okay, now you have to convert P to MR. So MR is 2.4 out of 45,000. Then you multiply it by 2, correct? No? So if you take 2.4 out of 45,000, you multiply by 2. That means you have to make this into 22,005. Oh, so that's how you convert it into 2. So your 2.4 45,000 divided 2 is 2.4 divide 225. Okay. Okay. So if you've got MR, now we must find what is MC. MC is the variable cost. And in this case, the variable cost is 5 plus 3 plus 3 plus 1. Material, labor, overhead, and selling overhead. So the variable cost is 6, 7, 12. MC equals to MR. 12 equals to 40 minus 2.4 divided 225Q. So Q is what? Okay. $262,500. So I maintain fraction, then I got no problem. If you rounded the figure, then later you cannot get back exact 262,500. Now this is my Q. So if you've got Q now, you will go on with the last stage. So your answer will be P equals to 40 divided by 2.4 out of 45,000 and replace it with Q. So 2.4 divide 45,000 times 262,500 minus 40. Your selling price is 26. Okay, now I said like example like this, 10 marks in the exam. Okay, so very simple steps only. You just need to know what to do, then you've solved the problem. Okay, alright, so I finish off this part with demand based pricing. Okay, we go for a break. We'll come